Imagine rewinding time, billions of years into the past, and witnessing the unfolding story of the universe from its fiery birth through to the complex cosmos we see today. This is the journey of the universe, a tale stretching 13.8 billion years, condensed into moments of wonder and awe. Let's start this incredible time-lapse of everything that has ever existed. It all starts with the Big Bang-on, incomprehensible explosion of energy that marks the beginning of time itself. Less than a trillionth of a second later, the universe began to expand exponentially, growing from an infinitesimally small point to vast cosmic expanse. This led to all matter, energy, and laws of physics we know of today. First, a few minutes elapsed, and in this universe, plasma abounded. Then protons bonded with neutrons to create hydrogen and a minuscule hint of helium, the first elements out of which atoms would eventually go on to constitute stars, galaxies, and living things. Fast forward 380,000 years. The universe cools, and for the first time, light can break free. This moment, called recombination, creates the cosmic microwave background radiation, a faint glow that scientists still detect today, a snapshot of the infant universe. For millions of years, darkness reigns. No stars, no galaxies, just a vast expanse of gas. But gravity begins its relentless work, pulling hydrogen and helium together into dense clumps. These clumps ignite, giving birth to the universe's first stars. These early giants burn hot and bright, living fast and dying young in spectacular supernova explosions. These explosions scatter heavier elements, carbon, oxygen, iron, seeding the universe with the ingredients for planets and life. Over the next billion years, galaxies begin to form. Gravity draws stars together into swirling collections, from small clusters to massive spiral galaxies like the Milky Way. Black holes emerge at the centers of many galaxies, consuming matter and shaping their environments. Galaxies collide and merge, triggering bursts of star formation and reshaping the cosmic landscape. About 4.6 billion years ago, in the Milky Way's outer spiral arm, a giant molecular cloud starts to collapse. At its center, a star is born, our Sun. Surrounding the newborn star, a disk of gas and dust forms. Over tens of millions of years, this material coalesces into planets, moons, and asteroids. Among them is a rocky world just right in the Sun's vicinity to harbor liquid water: Earth.
Earth's early history is tumultuous. Bombarded by asteroids and comets, its surface is a molten hellscape. But these impacts also bring water and organic molecules, laying the groundwork for life. As the planet cools, oceans form, and life begins. Simple, single-celled organisms that thrive in Earth's primordial soup. For billions of years, life evolves slowly. Microbes transform the atmosphere, producing oxygen through photosynthesis. Eventually, oxygen results in an ozone layer protecting the planet from harmful solar radiation to allow life to thrive on Earth. But then, about 600 million years ago, there is a sudden explosion of diversity, the Cambrian explosion. Now oceans fill with all sorts of complex organisms, shelled creatures, eye-full creatures, limbed creatures. The crusade to land develops as a means of plant, insect, reptile, mammal, and bird life. Among these creatures stands a primate that one day will stand upright and behold the stars. Humans. The universe keeps expanding in the meantime. Stars grow old and die. Some end their lives as black holes. Others explode their outer layers in wonderful nebulae. New stars are born from the leftovers. Roughly 13.8 billion years after the Big Bang, we come to now. The universe is immense and intricate, hosting billions of galaxies, and within each one of those, billions of stars. Humanity has grown into a species that understands where it stands within this cosmic account. We've designed telescopes that allow us to look at objects billions of light years away. We've even sent spacecraft to explore our own next-door planets and probes to venture out into interstellar space. But the story doesn't end here. The universe's future remains a mystery. Will it continue expanding forever, growing colder and darker as stars burn out? Will it one day collapse back into a singularity in a big crunch? Or could it evolve in ways we can't yet imagine? These questions remind us of how much we have yet to learn about the cosmos. From the cataclysmic birth of the universe to life, and even the dawn of human curiosity, the story of the cosmos bears testimony to the power of time and transformation. We are, while gazing at the stars, not simply seeing distant worlds, but witnessing the echoes of past history and catching a glimpse of our cosmic origin. The time-lapse of the universe reminds us of the great journey that brought us here, and the infinite possibilities that lie ahead.